Alright, so I want you to correct your car on a ramp flap. Um, anyway, Miss Pierce will hand this back to you. If you, for some reason, don't have one, you're absent or something, um, you can just go ahead and take notes on this, but I want everyone else to grade it, to grade what you did. And I'm going to take you through and show you the different points you would get for this. So, let's start off with that. Now this is going to be due at the end of class, so, make sure that you turn the center upward to work. If you have any trouble, let Miss Pierce know. Okay, so first of all, you were supposed to find the mass of an unknown object, which turned out to be a toy car that you could assume to be frictionless with the surface of the ramp you created because the wheels roll. And we'd have a known mass. This is a known mass. Ideal pulley, no mass, no friction. A light string, which we're considering to be massless. And you had a protractor to measure theta. And your tape and everything. This is pretty much all you need. First thing you need to realize is that acceleration of the system, which means the car and the weight and, everything, would equal 0. So, and you also want to remember, this is Newton's second law. Remember that acceleration is directly proportional to net force and inversely proportional to mass. So what you could say with these two things is, therefore, net force equals mass times acceleration, and all that would equal 0. And remember, once again, this is for Newton's, so let me write it, Newton's second law. Now this is going to deal with Newton's second law and Newton's third law. So basically, if you had the acceleration, you need to put plus 1. If you had either Newton's second law, this, or this, give yourself plus 1. And then if you had set net force equal to 0, give yourself plus 1. So basically, for this equation, it could be net force equals mass times acceleration. Acceleration equals net force over mass. I mean, I guess you could have solved it for mass too. That's kind of weird. Or you could have written Newton's second law. Any of those would work. By the way, if you don't have that, you need to fix it, and this needs to be done in a different color on the paper she gives back to you. So, anyway, so that's the first part. Let's look at the second part. You want to have a free body diagram for each object. I'm not going to draw them on here. Let's see. I'm going to go ahead and do the one on the ramp first. I'm going to redraw my ramp here. And actually, I'm just going to redraw the system because that'll be easier. We've got too much stuff written over here. There's my pulley. Alright, so I would draw maybe the car like this, and then put its center of mass right there. That's theta, of course. Okay, and then remember that you're going to weight always goes straight down, and that should be in G, and then it's always good to draw kind of a little guideline that's perpendicular to the surface. Weight has to be pointing straight down in this. Let's see, I'm going to do these other ones in different colors. Okay. So that's your weight. Let me do this. Now look, you know that you're going to have a part of your weight that pulls you down the ramp. And I'm going from my little guideline to this, and it should be pointing down the ramp. Right? You also know that the force of tension is going to be the same amount in the opposite direction because this thing is static. Okay? Label that. That is force of tension. I'll come back to this one in a second. And then let's see, then you know that another part of your weight is going to be going this way. And then you're going to have something the same amount pointing this way. Now you should know that this is perpendicular to your surface, so that is your normal force. This is a portion of your weight. Remember, theta is up here closest to the object, so this one right here would be your weight, it's closest, cosine theta. This is going to be your weight sine theta. Make sure this is right. You should be able to go through your force triangle here and look at it every step of the way. So this is for this object. Okay. The stream, and then this is going to be your known mass over here. Oh, let's call this R, so you can say unknown mass, and I'm going to call it MC, and I'll call known mass just M1. M1 and MC. Okay, so this right here, your weight, it should be M subscript C G to show the weight of the car. And these also is like, so this should be MCG, like little c, and MCG sine theta. So the C needs to be there, it's the big F mass. Alright, so this, on this side, you'd have, oops, I drew that big, but this is going to be M1G, that's what you know. You can call it MK, whatever you want to call it. And then smaller in the opposite direction, probably about the same size as this, you would have force of tension. Okay, so let's score this part. Okay, for having your weight pointing straight down and having a subscript, give yourself +1. Okay, for having your force triangle drawn correctly, so this is, I could have done this a little bit better, so this right here is parallel to the surface of your ramp, your mg sine theta, give yourself +1. This mg cosine theta is perpendicular to the ramp, +1. Force of tension, pointing that way, parallel to the ramp, +1. Normal force, perpendicular to the ramp, and they need to be perpendicular, not off this way, or up that way. Cannot be straight up and down, that's +1. So give yourself points for that. Okay, on this one, having weight pointing down and being bigger than your force of tension, it should be subscripted 1, +1. And the M needs to be subscripted, not the G. It wouldn't be MG1, it would be M1G. Let me see. And then for force of tension, +1. Also make sure that your T's here are capital. That'll be important because F little t looks like something else we'll use later. So that'd be 1, 2, 3, 4, 5, 6, 7. So if you put any other forces on this for some reason, which I don't think many of you did, take off a point, but I think you're good. Here. Okay, so you have that. Now, you can eliminate the force of tension, but this is what you would have to have written, and I don't think anyone had this. Okay. Okay, actually you can put ignore force of tension, and right above that, you can put by Newton's third law, ignore force of tension, or force of tension can be ignored. You could also have written I guess up here, you could have called this system. If you indicated that your system is not accelerating, that would be fine, or really though it's good to have Newton's third law. So give yourself a point if you put this, or if you had a cis. So I guess I shouldn't have a point there. So give yourself a point for that. So either this or cis or system equals 0. Let's see. So for the next part, we need to kind of put it all together. So since we're now ignoring force of tension, it should be pretty easy. What's pulling you? What's balancing out? Well, this is wanting to pull it down, so you know that M1G is going to equal, well, what's going in the opposite direction? Okay, so let's say that this is falling down kind of this way. What's pulling it to where it's not falling? So you know that if you've got like a force pulling the system like down like this, right? If you have a force doing that, then you're going to have a force pulling something down the ramp to balance it. So let's do it. Okay, well, the only one that does that is mg sine theta, or mc, that's the car, g, sine theta. Okay, so you're almost there. Give yourself 2 points for that. Alright, and then the last step, we want to solve for mc. So we have g sine theta. Cancels out. over sine theta, and you can absolutely do that, equals MC. So that's your answer. Give yourself 2 points for that. Now, anything that is not mentioned on here that you have, like kinematic equations or something else that doesn't make sense, take a point off for. It's not like scratched out. Look, I'm not going to grade these. Like, what I'm looking at is like how honest you are with this. Miss Pierce is watching. You should just have a different color pencil. I want you to have an honest evaluation of how you're doing on this. I'm doing this instead of a grade, but if it looks like, or I see a lot of people like changing stuff in the color they originally wrote with and then going back and grading it this way, this isn't going to be something I do again. I'd prefer to work this way, to where you see what your mistakes are. It's really no penalty. You get a grade for like completing the corrections and things. So it's up to you guys. If you're having trouble with the free body diagram, Miss Pierce is going to come around and help you. This is super important, being able to draw this. Make sure, I will probably be like, I don't know, I'm going to be making you prove that you know how to draw this before the 6 weeks is out. Just everything except your weights can be parallel to the surface or perpendicular to the surface. Just remember that. All right. Oh, yeah, and turn this in. Take a picture, turn it in.